Hello, sir. Good morning from the Philippines.
Yeah. Philippines. With the city. Hello.
Yes, sir.
Hello, sir.
You are from Philippines, right?
Yes, sir. I am from the Philippines, and it's
Philippines.
morning here.
Which country? Which city? Where is the city?
Okay, sir. I am now in Agusan del Norte, specifically in Butuan City in Mindanao Island.
Oh, Mindanao. Okay. How about the situation COVID-19 over there?
Okay, so the situation, sir, here is pretty much controlled, and we're still waiting to be fully vaccinated because of the lack supply of vaccine here in the Philippines.
Wow. What about the vaccine? That's now you got the vaccine, all right?
We have here available vaccines like Sinovac, AstraZeneca, Pfizer,
Yeah, that's all.
and Moderna also.
Uh-huh. Good, good.
Hello, everyone.
Yeah. Christine, right?
Yes, correct.
Yesterday I talked about the Win application, and then I took the article, my article. I share in the chat box. If you are interested, you can download from my chat box right now.
Sure. Thank you. I don't think I'm seeing, let me check. The chat box in Zoom, I'm not seeing it.
Zoom in the Zoom.
Yeah, I think because I joined in, maybe I joined in after you shared it, so I'm not seeing it.
Okay, maybe I share in the Gmail again.
Yeah, or maybe you can share later on when there's more participants, so then everybody can see it. Because I think what happens with Zoom,
Yeah.
you don't see the chat before you join in, like what was in the chat.
Shot.
Shot in the chat, you don't really see what's in it unless you're a part of the Zoom. So if you join in later, you wouldn't
Yeah,
see
yeah,
what's
yeah.
in it.
Okay. So welcome 11 people. So I'm waiting more, just around 4 minutes, 5 minutes. Waiting for some. Now it's coming.
Hello. Combined with arms building progress. Illiteracy is the best classification uses the facility use a via and previous from files. One size for installations at the high hydrogen high volume productions expect in 2020. Excellent capacity for productions and engine EV car. Hydrogen energy and
fuels. Suitable,
do you hear me? I think I'm going to start the lecture right now. I talk
Yes,
about
sir, we can hear you.
yeah. The question from Mr. Mark, right? Sachin.
Yes, sir.
Yeah, if for the commercial in the install at the southern of Thailand, it's quite big and very tall, just around 80 millimeter from the ground, just around 10 million. But the generate is a 1 megawatt. 1 megawatt will quite big. And now they develop to low speed. It means cut in. But I think you know now it's cut in, cut off, and wind race, because I lectured the yesterday, right? So so today I'm very pleasure to talk about the hydrogen. You ever heard of hydrogen? Hydrogen is the first element in the periodic table. Element is from water, because now we consume the fossil too much, and then your evaporate emission the carbon dioxide to the atmosphere, and now like a green gas, and make the climate change. So we are looking for the new fuels for the future. How can we separate or replace the fuel and become the take care the earth, right? So I think hydrogen is very planful, because always you are connect and touch the hydrogen, at least the water. But hydrogen is everywhere. But how can we transfer the hydrogen, become the power, become your car, become your everything, your activity? So now I'm going to talk like that. And I have a clip video, but now it's a very quite long. And then I talk about the topic first. And then if your mind, you can prepare the paper and writing up like a mind map. They don't serious. It's like if you are finished, can you take a photo to me and send to my fan page? I will interactive to you again, right? So I have a long about this, the hydrogens. I will talk about the hydrogen from the principle and going to eyeing up and to make understand and how to apply and why we need the hydrogen. And because right now it's okay expensive, but we have a choice or the method how we can reduce the price, and then in the future maybe every people can use hydrogens. Before it's very expensive and dangerous. I think you heard something is a hydrogen bomb, but now they have a tanks and safety than before, and how can connect to the business, like a benefits of the economics like this. Okay, the first one I'm going to talk about what is the hydrogen. Hydrogen is like the first element, only one atom, and have the electron around only one. So this is the base of the universe, the elements of the universe. And then I think it's easy. And hydrogen actually is from the sun. Everything, the energy is from the sun. It's like rain, wind, actually the force is from the sun. And then I talk about what's going on about the hydrogen. And hydrogen actually it is H2O, hydrogen and oxygen. It's become the water you drink every day. That's it, hydrogen. So in the future, fuel from the human and fuel for the car at the same thing. And also right now they have a hydrocarbon. It's like a benzene, methane, propane, butane. These are the hydrocarbon. It's like a fuel. This like right now. This also connect to the hydrogen. So they have the methodology how to split between the carbon and hydrogens out, and you can use hydrogen. And then if it2 can be renewable energy, but now it's many the country, like Kyoto in Kyoto or Tokyo at the Japan now is have a hydrogen city, and I saw in the Facebook or YouTube, South Korean also now is have the power plant of hydrogen also, and of course the car, because now they have a EV very popular about use the battery. But if you think in the long term, battery after degrade or finish it, no can use again. So it become what is it? Waste, electronic waste again. So, but this not finished just about the power. But hydrogens after you use, you got electricity to drive a motor and use for the EV car. The chemical combustion between hydrogen and oxygen become the water again, and then finish, everything is finished. So that's why hydrogen maybe in the future this is a new fuels, right? Another one, you can use a steam reformer. Steam reformer is mean hydrocarbon from the methane, from butane. You can split carbon and hydrogen out and become the hydrogen you can use again, right? Another method, electrolysis. Electrolysis is my research. I have a clip video about the use of wind turbine to split the water and collect the hydrogen for use in fuel cell, and fuel cell generate the electricity again, right? So electrolysis very interesting in the future. But now it's a very expensive because they use electricity from the main power. But whatever, if in the future you use from the solar cell and wind turbine, the cost will be reduced and become the low cost, and all the people can use it. All right. Another way, but now they have many researchers going to do photoelectrolysis. Use the sunlight to split the water. You can get the like electrolysis. You can get oxygen and hydrogen too, and water will come to the field like this. But I have this one. I did before, very slow, but sometimes take a time also. So photoelectrolysis, maybe you need a big scale or human abundant scale, and you can do and take a lot of the area to do this one. And we need semiconductor to do split the water from sunlight. Another method for split the water is, but it's used a biogas, like a gasifier. So you can burn the wood, and then the wood can apply, release the hydrogen also. So this one, the biogas. Another one, they have a research, but not too much. They use the sunlight and bacteria. It's like a fermentation. If you put many things in the water, they have the gas, right? And gas can split the sea, use the bacteria, but very slow also. And we need the big scale. You can get a good hydrogen in there. But now they have many people use this one because they have a wastewater, and then you have a fermentation and get the gas. Another one is you see in the now is Elon Musk that have a rocket. Rocket is use hydrogen for the fuel for move the rocket. Another one is food process industry. So many things about the hydrogen. So hydrogen, that's why in the future. But now they are going to how to prove to safety, because if sometimes easy to explosion. So now they have a tanks, fiber tanks. So it's a very safe because I have a research to use this hydrogen collect in the tanks. So if some the accident explosion. These are like a carbon fiber and open, very safe. No accident from this one. And the highlight of my explain my lecture, I use the wind turbine. Yesterday I show you is the first project at the dam Ratchaprapa province in Thailand. But the second project is a use a wind turbine also. I install at the Krabi province, and then after we got the electricity, we connect to the electrolysis, and use the seawater put inside, and then you can split the water, got the hydrogen and oxygen also. But I release oxygen out. I collect only the hydrogen only. And I have a detail in the clip video. So the next question, after you got the hydrogen and how in the next, you got hydrogen, it's like an energy storage, like you do in the battery. Battery is like an energy storage, right? Because if you want to use, you can use the battery and then put to electric equipment, and then it's run the operate. When you collect the hydrogen also at the same system, hydrogen will be converted to electricity by fuel cell. So fuel cell, I have this is my fuel cell. I have shown in the clip video. Fuel cells can convert to electricity by use the hydrogen and oxygen. Oxygen you can use from the air. The air is have hydrogen just around 21%. But if you use pure oxygen, it's high power too. And really highlight about the hydrogen car. So now it's have a competition in the factoring about the Toyota, Honda, and GM. Sorry, they have a between EV and hydrogen car. So how we in the future we can get that one. But now EV in the battery, lithium ion, lithium solid state is coming. But I will talk about this one, about the battery after done, after finished. How can you do again? But if you use hydrogen will be clean 100%. Okay, these are the highlights of my talk, and then I show you the clip video now.
Hello everyone. I am Assistant Professor Dr. Montri Leungchawanon from Faculty of Environmental Management, Prince of Songkhla University. Today I have a topic for lecture hydrogen energy and wind application. Before my lecture, please prepare the paper for my lecture. While I am lecturing, please use the mind map for sucking the knowledge from me. After my lecture is done, please upload your mind map in the inbox on the Facebook fan page. The first, sustainable energy management. Second, Thai energy man. And if you have any question, please put inbox of this Facebook fan page. I will reply all your questions. What is the hydrogen? Hydrogen is the simplest element known to exist. Atom of hydrogen has one proton and one electron. Hydrogen has the highest energy content of any common field by weight, but the lowest energy contains by volume. It is the lightest element and the gas at a normal temperature and pressure. What is hydrogen? Hydrogen is also the most abundant gas in the universe and the source of all the energies we receive from the sun. The sun is basically a giant ball of hydrogen and helium gases. In a process called fusion, hydrogen nucleus combine to form one helium atom, release energy as radiation. This radiation energy is our most abundant energy source. It gives us light and heat and make a planet grow. It's got the wind to blow and the rain to fall. It is storms and chemical energies in the fossil fuels. Most of energy we use originally came from the sun. Hydrogen as a gas H2, however, doesn't exist naturally on Earth. It is found only in a compound form. Combined with oxygen, it is water H2O. Combined, the carbon is the form of organic compounds such as methane, CH4, coal, and petroleum. It is found in all growing things, biogas. Hydrogen is also one of the most abundant elements in the Earth's crust. Most of energy we use today came from the fossil fuel. Only about 9% come from the renewable energy source. Usually, renewable energy sources are cleaner and can be replenished in a short period of time. Hydrogen can come from either renewable energy or non-renewable energy resources. Every day we use more fuels like coal and natural gas to produce electricity. Electricity is the second source of energy. Second source of energy, energy carriers are used to store, move, and deliver energy in easily and able form. We convert energy to electricity because it is easier for us to transport and use. Try splits and atoms, building a dam or burning a coal to run your television. Energy carrier make a life easier. Hydrogen is one of the most promising energy carriers. It is high efficiency, low pollution fuel that can be used for transportation, heating, and power generation in a place where it is difficult to use electricity. How is hydrogen made? Since hydrogen gas is not found on the Earth, it must be manufactured. There are several ways to do this. Industry progress. The hydrogen is needed by a process called steam reforming. High temperature steam separates hydrogen from the carbon atom in methane. The hydrogen produced by this method doesn't use it as fuel, but for industrial progress. This is the most cost-effective way to produce hydrogen today, but it uses fossil fuels both in the manufacturing process and at its source. Another way to make hydrogen is by electrolysis. Split the water into basic elements, hydrogen and oxygen. Electrolysis involves the passing an electric current through to the water to separate the atoms in the equations. 2H2O plus electricity equal to H2 plus oxygen. Hydrogen collects at the cathode and oxygen at the anode. Hydrogen products produced by electrolysis is extremely pure, and electricity from a renewable source can power the progress, but it is very expensive at this time. Today, hydrogen from electrolysis is 12 times more costly than natural gas and 1.0 times more costly than gasoline per BTU. On the other hand, water is abundant and renewable energy and technological advance in renewable energy. Renewable electricity could make electrolysis and more attractive way to produce hydrogen in the future. There are also several experimental methods of producing hydrogen. Photoelectrolysis use the sunlight to split the water molecules into its components. Second, conductors absorb the energy from the sun and act as an electrode to separate the water's molecules. In biogas gasification, wood chip and agricultural waste are superheated until they turn into the hydrogen and another gas. Biogas can also be used to provide the heat. Scientists have also discovered that some algae and bacteria produce hydrogen under the certain conditions. Use the sunlight as their energy source. The experiments are underway to find a way to induce these microcrops to produce hydrogen efficiently. Nearly every region of the countries and the world has one or more resources that can be used to produce hydrogen. It can be produced at the large central facility or at the small distributed facility or local use. One of its main advantages is the flexibility. Most of this hydrogen is used for industrial applications such as refining, treating metals, and the food processing. Liquid hydrogen is the fuel that once propels the space shuttle and another rocket. Hydrogen fuels powers the shuttle electrical system, produce a pure water, which was used by a crew and driving the water. In the future, however, hydrogen will withdraw electricity as an important energy carrier, since it can be made safely from renewable energy source and is virtually non-polluting. It can also be used as a fuel for zero emissions vehicles to its homes and office. To produce electricity and to fuel aircraft, cost is a major obstacle. Future of hydrogen. The use of hydrogen raises concern about the safety. Hydrogen is a volatile gas with a high energy content. Early, the skeptics had a similar concern about natural gas and gasoline, events about electricity. People were once afraid to let their child too near the first lights above. As the hydrogen technology develops, safety issues will be addressed. Hydrogen can be produced, stored, and used as a safety as another fuels. As the domestically produced fuels, hydrogen has the potential to reduce our dependence on foreign oils and produce clean, renewable energy for the future. Wind energy and productions of hydrogen and electricity. Hydrogen can be produced from variety of domestic and renewable source of energy. And assessment of the top options for wind hydrogen electricity system at both central and distributed scale provides insight into opportunity for renewable hydrogen as well as research priorities for hydrogen produced pathway. The analysis of the central productions of hydrogen from wind as conducted. This technology involved hydrogen production at the wind site, with hydrogen delivered to the point of use. The result of this study are that hydrogen can be produced at the wind site for the price range from 5.5 per kilogram in the near term to 2.27 per kilogram in the long term. A research opportunity in these scenarios is eliminated for redundant controls and the power electronics in combined turbine electrolysis system. Electrolysis is the production of hydrogen from the water. An electric current is passed through an anode and a cathode in contact with the water. The next reaction which occurs is 2H2O liquid plus electricity become 2H2 plus O2. One site was installations at Krabi province, Thailand. The wind turbine system site was chosen as the PH University is in process of being wind hydrogen research and is partnering with the directories of provincial administrative organization PAO Krabi. This site had an average wind speed of 5 meters per second. Hydrogen technologies are in the early stage of the market introductions. They store hydrogen at average height. Pressure at 700 bars for fuel cell drive EV electric vehicles. The first generation is used osmosis filaments winding with the standard T700 carbon fiber. Hydrogen tanks. Why? Because a high demanding application for EV with a fuel cell. Extreme pressures 700 bar require carbon fiber. High volume production expect in 2020. Excellent capacity for production and engine EV car. Hydrogen energy and
Fields. Suitable high qualities of life is the basics driver for providing
Okay. How is it? It says I explained about the hydrogen. Hydrogen is very abundant on the earth. So how can we produce the hydrogen? But now, before in the past, the hydrogen very expensive and very dangerous. But now that's going to produce easier and like electrolysis. Electrolysis before we use the main electricity, right? From the main electricity, so you pay. But now we connect to wind turbine. I show you in my project, the second project from the wind turbine to split the water from the sea water, and we can collect the hydrogen to the tanks, and then we can use this one for the energy storage also. However, if you know the wind turbine, you can use the solar cell also. I will use solar cell for split the water by electrolyze, use the power from solar cell, and then you can got electricity also. Hydrogen. So now hydrogen is going down and close to you to use. Maybe in the future it's close. I talk about the tanks because tank before expensive, but now it's going down. The price low cost because it can collect the hydrogen just around 700 bar. So you can connect to the hydrogen car in the future. But now it's everything is have a competition about the EV and hydrogen car. All right. I talk about this one. Why we need use the seawater, because if you normally you use electrolysis, you connect the electricity from the wind turbine or solar cell or the main power and put the water, only the water, not easy to split the water, the water become to hydrogen and oxygen. We need to use something. That thing is salt, sodium hypochlorite. If you put something and easy to faster to split the water. So if you use the seawater inside have a salt inside, so no need to put the water the salt inside. You can take the water directly and put, and everything is you can only apply the electricity and then you can get the hydrogen directly. Another one I add in this my experiment. If you see in my video, I use the carbon, but many people use the metallic electrode put in the water and split the water, because I ever use about the metallics. Metallic is you can get hydrogen, but you can get the feel, the smell, depend on the electrode. So if you collect the hydrogen and check with the gas GC, gas chromatography, hydrogen is contaminated with the gas matter. If you use the Fe ion, you can got the ion. If you put the electrode with the aluminum, you can get aluminum. So if you use the hydrogen to fuel cell is not take a long term, will be contaminated with the ion. That's one. So in my clip video, I use the graphite. If you see very black, graphite is good conduct. If you apply the positive and negative, the DC direct currents, and then the positive you got oxygen, negative you got the hydrogen. hydrogen very purified about the hydrogen you can use directly, but they have a disadvantage because if you use the meta in the long term, you take a time maybe 1 month or 3 months, but the graphite take maybe 1 month. It's broken because they have a electrochemical like a carbonized and broken. These are like a trade-off always, because if you got the sometimes it's good, another one you can lose. Okay. Do you have a question? If no question, I'm going to the next slide. Next slide, I'm going to.
Sir, excuse me.
Yeah.
I have a question, sir. In the chat box.
Yeah. What?
In the chat box.
How can I collect the hydrogen, right? I have a pump because of my electrolytes that split the hydrogen, because in the positive we release the oxygen and negative release the hydrogen. So when the electrode put in the stack, this speedily the gas hydrogen, and gas hydrogen go to connect to the pipe, but they have a valve for when hydrogen is moved up, and then the pump is sucking go to the fiber tanks.
Okay, sir, I understand, because hydrogen is a very light gas, so it
Yeah.
settles on top of
Yeah.
the tank, so that the pump will be placed on top of the cylinder. So the only gas that will be pumped out will be hydrogen. Okay, sir, thank you.
Yeah. But your oxygen should be released far away from hydrogen, because if the pure hydrogen and oxygen close each other, easy to it's like a crack sound. So if possible, when you got the hydrogen, right, hydrogen and oxygen, maybe you can release or put the fan to dilute the gas. It's better, because if you have a like a flare or the lighter near, easy to crack and have a sound like an explosion. But
Yes,
if
yes, sir.
yeah, these are my experience. Okay, thank you. Your question. Okay, we have a time, right? Okay. In the next, I talk about the hydrogen and fuels, and why the hydrogen is they are currently about the green power and no toxic, no anything, because when after we release, this is the green, no effects to the atmosphere and the rain, anything, no carbon dioxide, and also in the air, when you breathe, they have hydrogen also inside, but not not too much amount. That's one, and environment friendly, right? So I have an example in the Europe, because Europe very active about the hydrogen power. And also I talk about the car many times, but now I live in the car, because now it's a Toyota. Maybe you have seen in the Facebook or YouTube or the TV program about the uh, Toyota agency make a road car, and then Honda also and GM also they have a car, but not popular like a EV. But maybe in the future, because now it's hydrogen is going up high technology, and if they can produce mini the gas stations like a gasoline station, hydrogen car will be coming, right? And if we can recharge the station hydrogen, and high power of the density hydrogen will be easy to use. And but now is I have the highway of the Europe. At the Europe, they will install the gas station about the hydrogen to move about the hydrogen power in the future, because the first one, water, you is very available, not like oil. Oil you should go to the cow sucking from the earth, but now the earth is very painful. And aeroplane, maybe in future they have hydrogen, if very safety and easy to use, right? Okay, I'm going to the next my clip video.
Hydrogen energy and fuels. Sustainable high qualities of life is the basics driver for providing a green, safe, reliable, and secure energy supply in Europe. To ensure competitive in economics environment, energy system must be the following societal need at affordable price, mitigate the effects of the climate change, reduce toxic pollutants, and plan for diminishing reserve of oil. Failure to meet this need will have a significant negative impact on the economics, the environment, and public health. Measures should therefore be introduced which promote more efficient use of energies and energy supply for growing proportions of a carbon-free source. Hydrogen powered cars are feasible in practical propositions by Roberto Sarreco. He is the senior member of IEEE. In the figure is hydrogen powered car are feasible in practical propositions. Schematics of hydrogen powered car. In the yellow, the hydrogen tanks feeding the fuel cells gray that produce electricity for batteries. Image credit fuel cell store. Hydrogen conversion into electricity stores fuel cells, a green way to transform energy. A car powered by hydrogen would generate just water as a waste produced. No pollution whatsoever. This is what is called local green. Since cobalt's greeniness depend on how the hydrogen is produced. Hydrogen is good because it has a high energy density. So it makes sense to store in the tanks on a car and convert it locally into electrical power rather than relying on recharging stations. The energy of 1 kilogram of hydrogen is equivalent to the 1.2 kilogram of gasoline. The situation is more complicated because you can store the liquid gasoline at the ambient temperatures at the pressure. Releases you need to lower the temperature of hydrogen to an extremely low point or increase the pressure to very high value to store hydrogen as a liquid. Increasing the pressure is the approach used for the storing hydrogen in vehicle tanks. We have seen several prototypes of hydrogen-powered car, but no real commercial one. Honda has announced they have discontinued their carbureted fuel car. GM, on the other hand, continue to produce a fuel cell, but they are not planning for their use in the cars. The big problem in using hydrogen in the cars is the abilities of refueling station. They are nowhere to be seen, and it makes little economic sense to create just infrastructure because it is a cost. It is classical chicken and eggs problem. There are not a sufficient number of cars that would be used just an infrastructure, but without the infrastructure, no one is going to consist buying an hydrogen powered car. Europe have launched a European hydrogen highway, the flagship initiative aiming at the creation of a refueling points on the major Europe highway to support fresh hydrogen-based transportation. On the side, you can see the plans covered with hydrogen refueling station European highways. The map represents the expected coverage at 2040, 20 years for now. Looking at the links document, you can see what little the coverage exists today and how much time is expected to achieve the target development. Europe as an example. The situation in another areas that are starting to consider hydrogen as a fuel is not that much different. It is evident that this is not designed for the car, but for French trucks. Although the complex and expensive, the development of electrical recharging points is easier, and that is what is the happening for the car. This explains the more of the Honda and one of the GM abandons hydrogen power car and focus on the low earnings French represented by real transport first, freight trucks at the second target, and possible airplane in the this feature. In the figure, plan the coverage of the European highway by 2040 with hydrogen refueling station. Image credits the Guys House Matrix Forums, October 2020. energy security and supply.
Okay, so from my clip videos, I can conclude like this. Because many the agency of the Toyota, Honda, or GM, they have a plan to do this one, but not only a car, but maybe the power plants like that. But the problem is gas hydrogen is not costly. They're still expensive. So that's why I talk about if you use renewable energy to split the water like electrolysis, so easy to collect the hydrogen, and hydrogen will become low price. So in the future, if we can develop this one to high technology, we can make a gas station like a Europe right now, because now it's 2021, right? But the plan for the highway gas station is 2020. And from the figure they have a car, right? Have a car, and then that's the car they use a fuel cell and still use a battery, because when you use a battery, have a tanks of the hydrogen. When you top up the hydrogen, and hydrogen create the hydrogen to the fuel cell generate electricity to go to the battery again. So sometimes it's like confused, because why fuel cell not go to the motor and drive the wheel of the car can be moved. Maybe this is like for support about the when the fuel cell is not comfortable. But actually no battery, we can use the fuel cell and hydrogen directly. That's in the car. I talk about this one about the fuel cell. Fuel cell actually they have a many type, but in the car they use this one. This is a PM, polymer electrolyte membrane. I have a clip video in the last time. Another one is called the solid oxide fuel cell. This is no need to use a high temperature. You can use the oxygen and hydrogen directly, and then connect the electrode to sucking the electricity, and you can use for the drive motor or the power plant to some equipment, electrical equipment directly. But they have another one, solid oxide fuel cell. This one is like a ceramic. When you use, you should heating up, and you can put oxygen and hydrogen also. And also this is cheaper. When cheaper, should be heating up, like a put in the chamber and heating up. But this one is no need to put in the high temperature. But the problem, because this have a rare earth inside. Rare earth, for example, is like platinum. So platinum is a very expensive element. So maybe but right now is the researcher going to research how we can make a polymer electrolyte membrane lower the price, and some element can change the platinum, and then we can get the fuel cell in the low cost. And another one, if you check from my clip video, it's 1 kilogram of hydrogen become 2.8 kilogram of gasoline. So hydrogen is really very powerful than the gasoline, and no carbon dioxide also. Okay, the next topic is still involved about the hydrogen, but they are going deep to the economics and facility, and then how the economic competition and how the develop in the European, because these are European very active about the hydrogen. I will take for some know-how about this to explain to you. Okay, about the cost, how to promise to reduce that one, and hydrogen I explained in the last section is about the wind because I work in the experiment of the wind to split the water. Sorry, but now I have many the domestic power like a green power to split the water, like a solar cell. Ocean is mean wave power and many things you can split the water, and then use the hydrogen very powerful. And flexible about the hydrogen, maybe you can use for the power plant generate electricity directly can, and flexible for the heating up for the heater like in the Europe when the winter, that are very flexible. And also you can use in the like a mountain size because some the highest land in the UK United Kingdom they have the hydrogen's power for the highest land also and the mountain size also. Of course, in the transportation, because I talk about the car, so that exactly to use in the car. And also, if we can competition with the fossils, fuel now is good for economics in the future. If we develop the high technology for the hydrogen's power, and now it's exactly low cost, and then no carbon dioxide emit to the atmosphere as our Earth, so the no greenhouse gas, so will be the green energy. In Europe, at a high generate hydrogen storage, and maybe this is the ones of the traveler for the hydrogen technology. And also from the research, they report about the if use more hydrogen, so no carbon dioxide, no N2, no many the toxic of the air pollution, so the good air quality and health improve it. So that's why the hydrogen based solution is the zero pollution. So fuel cell is can generate it maybe in the future use it a fuel cell hydrogen fuel cell to generate electricity 100%. So hopefully will be planned for the future. So I have the table for the plan, like a report from Europe about the carbon dioxide in the year of 2020, sorry, 2030 and 2040. So how we need to reduce the carbon dioxide. We have a table to explain. They have hopefully we can reduce the carbon dioxide in 2040 240 metric ton of the carbon dioxide, and also in the future fuel cells be the powerful in the future. But now they have not the Europe is the first for the fuel hydrogen city, but the Kyoto is have a prototype for the all around the world. Okay, I want to show you about in the my clip video.
Today, society depends crucially on the uninterrupted availability of affordable fossil fuels, which in the future will be increasingly concentrated in a smaller number of countries, creating a potential for geopolitical and price instability. Hydrogen open access to a broad range of primary energy sources, including fossil fuels, nuclear energy, and increasingly renewable energy sources such as wind, solar, ocean, and biomass, and they become more widely available. Thus, The abilities and the price of hydrogens as a carrier should be more stable than any single energy source. The introductions of hydrogens as energy carriers alongside electricity would be able Europe to explore a resource that are the best adapted to regional circumstances. Hydrogen and electricity also allows the flexibility in balancing centralized and decentralized power based on managed intelligent grid and power for remote locations such as Iceland and mountain sites. Decentralized power is attracts both of ensure power quality to meet the specific customer need, as well as reducing the exposure to tourist attack. Our ability to store hydrogens more easier than electricity can be helped with the load leveling and balancing the intermittent nature and renewable energy sources. Hydrogen is also the one of the few energy carriers that enables renewable energy sources to be introduced into a transport system. Economics competitiveness. Since the first oil crisis in 1970, economic growth has not been directly linked with the growth energy demand in the industrial sector, whereas in the supported sector, increased mobility is still leading to a proportionate increased energy consumption. The amount of energy needed per unit growth must be reduced, while the development of energy carrier and technology to ensure low cost energy supply is not great, is of great importance. Development and sale of the energy system are also the major components of wealth creations, from automobile to complete power stations, creating substantial employment and export opportunity, especially to industrializing nations. European leadership in hydrogen and fuel will play a key role in creating high quality employment opportunities, from strategy R&D to produce and craftsmen. Air quality and health improvement. Improve the technology and post-combustion treatment for conventional technologies are continuously reducing the pollution emissions. Nevertheless, oxide of nitrogen and particulate remain a problem in certain areas, while the cobalt trend towards urbanizations emphasizes the need for the green energy solution and improve the public transport. Vehicles and stationary power generation fueled by hydrogen are the zero emission device that the point of use with the consequent trials local and quality benefits. Hydrogens can be produced from carbon-free or carbon-neutral energy source, or from the fossil with carbon dioxide capture and storage sequestrations. Just use of the hydrogen could eventually eliminate greenhouse gas emission from the energy section. Fuel cell provide efficiency and green electricity generation from a range of fuels. They can also be designed across to the point of end use, allowing the exploitation of heat generation in the process. The table illustrates how, in the major hydrogen-oriented economics, the introductions of the zero carbon hydrogen fuel cells vehicle could be reduced average greenhouse gas emission from European passenger car fleets compared to the average level of 140 grams per kilo carbon dioxide projected for 2008. The last column shows the corresponding amount of the carbon dioxide emission that could be avoided. This may be compared to the projected total level 750 to 800 megaton carbon dioxide emission for road transport in 2010. The number of hydrogen fuel cars are the assumptions based on a survey for experts for conventional and alternative automobile drivetrain, but not a prediction for the future production or sale. Greenhouse gas saving amount about 140 megaton carbon dioxide per year, just around 14% of today's level carbon dioxide emission from electricity generation. Could be achieved if about 17% of the total electric demand currently being supplied from a centralized power station is replaced by a more efficiency decentralized power station incorporating with stationary high temperature fuel cell systems produced by natural gas. Fuel cell system will be based on a load in the future decentralized energy system. These examples are not proposed as a target, but nearly to serve as illustrations of the carbon dioxide saving that could be achieved with quite moderate penetrations of the hydrogen vehicle and fuel cell based station power generation. To get the 15% regenerative hydrogen vehicle and above distributed fuel cell or gas turbine hybrid system could deliver about 250 megaton carbon dioxide saving per year. This approximately 6% of the energy related to carbon dioxide emission forecast in 2030, and progress suggests the world allowed European move beyond the Tokyo Protocol.
Okay, welcome back. So that's one I can conclusion about this. In the right now, it's a many the sections, many the department, many the government is going to drive the green energies. So in the ones of the green energies, hydrogen very interesting because it's abundant around the world. All the country you can use water, and then about the health, about the air pollution, about the greenhouse gas, its effect to the all the gas, all the pollution, and then this hydrogen is one of the solutions, right? Um, okay, I'm going to move to the last sections about this today. Before I talk about the hydrogen too much, and then hydrogen, we know only the energy storage, like a gas from the water, right? And then now you choose an element to convert the hydrogen to the power, like electricity, and to change to heat anything from the equipment. And then I forgot to fuel cell again. Fuel cell, I have a show this one. Fuel cell, in the clip, you have the constructor inside. And another one is a battery, because now very popular the batteries. This is a battery. This is a lithium ion oxide. And also this the energy storage the same. This can use when you generate the power, you need the hydrogen and oxygen apply inside, and then you collect this one to the electricity, right? This also, but no need the hydrogen and oxygen, only the 1 DC to charge. And when full, you can use this for the electricity also. Another one is my research also. This we call the supercapacitor. Supercapacitor also use the electricity to charge here, and then it collect the electricity like a battery. So how can the difference between supercapa and battery? Supercapacitor take only a short time to charging, only the second or the 1 minute. Very easy to charge and very easy to release also. So this take a time, right? Maybe maybe 6 hour, 1 hour, very fast. And also this use a electrochemical to reaction inside and have a heat up. If you have a mobile phone, right? When you plug in and charging your mobile phone, if you touch the back side, you can feel hot. But in this one is no hot, but very fast. The capacity not cannot the equal to the battery. But in the future, maybe it is very good, because the element, this one is from a lithium, right? Inside have a lithium and cobalt, carbon something. So sometimes inside is have a rare earth. So rare earth very expensive. And if no efficiency, you need to throw away. This is the electronics waste again. But this inside have activated carbon. Activated carbon produces from the wood, from organics. So organics is very environmental friendly with many things. When you throw away, that not matter, because these are no active to your pollution. This one only the prototype, but only the 1 gram. So after your form is like this. Okay, so I talk about this one because you have a fuel cell, you can use up hydrogen and generate electricity, right? Like the equipment. both of the energy storage, they have a 3 layers as the same as the first one is cathode, positive side. In the middle, it's electrolyte in the middle side, and another side is anode in the negative side. Both of it have the same. So this section, I'm going to compare. So both the three of this energy storage. This is the energy storage in the future is coming. This installed in the car, and it's sure maybe the next year, all the car in electricity on your car, you can use the EV car. No need to top up the gasoline in the future. And maybe this one also, or this one. So depend on which one is high technology and competition in the market on the world. So the next section I will talk about what's the battery, fuel cell, and supercapacitor. So supercapacitor now is the company can develop very high. They call this ultra capacitor. It's high level than that one, so it's quite big like this. In the Europe, like Canada or America, they have a butt cap. Butt cap is mean butt. Use a power supply from the supercapacitor or ultra capacitor, so they call the butt cap. So you charge around 1 minute full, and then you can use it's like a top up the gasoline. But battery you take a time. But battery now is the next step to the solid state. I think you ever heard the solid state also, but always it's chemical. So this is the elements for the battery and fuel cell. All that's one like this one and this one, all the energy you can charge from the green energy like a solar cell, wind turbine. So anything about the power, green power, and you can use this one to convert to electricity. So in the future, you can absorb the green power, no pollution, no carbon dioxide, right? So anyway, this one also we need to charge and discharge. So now it approved to take a time or not. And if the fuel cell, we need the gas hydrogen to support. But now it cannot move on because we need the gas station, right? Another one is I have a graph to compare post office, because now not only the fuel cell, supercapacitor, and battery in the market, they have a gasoline inside. Gasoline is mean the combustion section, right? And another one is a capacitor. Capacitor is like an element in the electronic circuit, but that's it, the field amount of the electricity to compare between the watt hour per kilogram. Watt hour per kilogram, because it's like this one, you use how much the material inside, how much kilogram can collect the electricity inside, how long is it, how much is it, and then how much you can provide the electricity, watt per hour per kilogram. Okay, so we call this a Ragon figure or Ragon chart, and you can check this one. Okay, I will show you the clip video. This shot around, this take a long time. And then after, if I have a time, I have a research for the publication to show you about what's going on. It's my research again. Okay.
What are batteries, fuel cells, and supercapacitor? Energy combustion productions that's really on the combustion of fossil fuels is forecast to have a serve future impact on the world economics and ecologies. Electrochemicals energy production is under the serious considerables as alternative energy power sources. As long as this energy consumption is designed to be more sustainable and more environmental friendly, systems for electrochemical energy storage and conservation includes the batteries, fuel cells, and electrochemical capacitor (ECS). Although the energy storage and conversion mechanisms are different, there are electrochemical similarity of these three systems. Common features are that the energy providing process take place at the place boundary of the electrolyte interface, and that electron and ion transport are separated. The figure shows the basic operations mechanisms of the three systems. Note that the batteries, fuel cells, and supercapacitor all consist of the two electrodes in contact with an electrolyte solution. The requirements on electron and ion conduction in electrode and electrolytes are given in the figure and are valid for all the three systems. In the batteries and fuel cells, electrical energy is generated by conversion of electrical energy via reduction reactions and the anode and cathode. At reactions at the anode usually take place at the lower electrode potentials than at the cathode. The term of negative and positive electrode indicated at minus and plus poles are used. The more negative electrode is designed the anodes, whereas the cathodes more positive one. The difference between the battery and fuel cell is related to the location of energy storage and conversion. Batteries are closest system with the anode and cathodes being the charge transfer medium and taking an active role in a reduction reaction at the active masses. In other words, energy storage and conversions occurs in the same compartment. Fuel cells are open systems where the anode and the cathodes are charge transfer medium and the active masses undergoing the redox reactions are delivered from the outside of the cell, either from the environment, for example oxygen from the air, or from the tanks, for example fuel jet, hydrogen and hydrocarbons. Energy storage in the tanks and energy conversion in the fuel cells are just locally separated. In the electrochemical capacitor or supercapacitor, energy may not be delivered via redox reaction, and thus the use of the term anode and the cathode may be not appropriate but are in the common usage. By orientations of the electrolyte ion at the electrolyte interface, so called the electro double layer EDLS, are formed and released, which result in a parallel movement of electrons in the external wire, that is in the energy delivering process. In comparisons, To supercapacitor and fuel cell, battery have a found by far the most applications market and have an estimated market position. Whereas the supercapacitor have found niches market as memory protection in several electronic devices. Fuel cells are basically still in the development state and are searching to find a killer application that allow their penetrations into the market. Fuel cells estimated their usefulness in a space application with the advance of the Gemini and Apollo space programs. That the most prominent features market for fuel cell and the supercapacitor are in the same application section as batteries. On the other hand, the word supercapacitor and fuel cell developer aim to complete with or even to replace the battery in the several applications areas. Just the fuel cell which originally were intended to replace combustion engine and combustion power source due to possible higher energy and conversion efficiency and lower environmental impact, are now under development to replace the battery to the power solar telephone and notebook computer and for stationary energy storage. The motivation for fuel cells enter the battery market is simple. Fuel cell cannot compete today, but combustion engine and gas steam turbine, because these are much higher cost, inferior power and engines performance, and insufficient, durable and lifetime. With operations time of typical lower 3,000 hours at the least and order of the magnitudes. Similar to cost, battery are less strong competitor for fuel cell. The terms specific energy expressed in watts-hour per kilogram and energy density in watts-hour per liter are used in the compare the energy content of a system, whereas the rate capacity is expressed as a specific power in watts per kilogram and power density in watt per liter. Alternatively, add the attributes gravimetrics per kilogram and volumetrics per liter are used to compare the power engine's capability and represents known as the Rogan plot or diagram has been developed. Simplify Rogan plot figure in the figure. Disclose that the fuel cell can be considered to a high energy system, whereas the supercapacitor are considered to be a high power system. Battery have intermediate power and energy characteristics. There is some overlap in the energy and power supercapacitor of fuel cell with the battery. In this battery with a thin film electrode exhibit the power characteristics similar to those of the supercapacitor. Moreover, there are also hybrids such as metals air battery, or in the other world the metal air fuel cell, which contain a battery electrodes, metal anode, and the fuel cells electrodes and cathodes. Finally, in the figure also show there's no single electrochemical power. sort and match with the characteristics of the internal combustion engine, high power and high energy, and thus are competitive behavior in a comparison to combustion energy and turbines can be achieved with when the available electrochemical power systems are combined. In such a hybrid electrochemical power batteries and or supercapacitor would provide high power and the fuel cell would deliver high energy. Figure show the electrochemical specific engine kilowatt-hour per ton and energy density kilowatt-hour per cubic meter of various recharge battery system in comparisons of two fuels, just as the gasoline, natural gas, and hydrogen. The inferiority of the battery is evident. The figure showing the traveling strength of the battery power car in comparison to a car powered by a modern combustion engine give impressive example for why fuel cell and not battery are considered for replacement of a combustion engine. The theoretical value in the figure are an indication for the maximum energy content of a certain chemistries. However, the practical value different and are significantly lower than the theoretical value. As a rule of thumb, the practical energy content of a rechargeable battery is 25% of its theoretical value, whereas a primary battery system can use over than 50% of it. Theoretical value is the delivers energy. In the future, fuel cells might be able to convert the used fuels into electrical energy with efficiency of over than 70%. The difference between the theoretical and practical energy storage capability is related to several factors, including the first, insert the parts of the system such as conductive, dilute, current collectors, containers, and so on, that are necessary for its operations. Second, internal resistance within the electrode and electrolytes and between cell and battery components, resulting in internal loss and thus limited utilizations of active mass. As for example, the parts of the fuel in the fuel cell leave the cell without reactions, or for example passivations of electrodes mark them partially electrochemical inactive. However, as the battery and fuel cell are not subject to the Carnot cycle limitation, they may operate with a much higher efficiency than combustion engine and related device. Vanity and environment in the end. Please don't forget send your mind map from my lecturer to Facebook fan page in sustainable energy and Thai energy men. Thank you for watching.
Okay, I can explain more about the between the battery and supercapacitor. I think battery you are very familiar with the right now about the battery, because now it's going to use all the battery. but I explain more about the supercapacitor. This one, supercapacitor, because when they active to collect the electron inside, then this use the chemical reaction between anode, electrolyte, and cathode. But this use the activated carbon to the electrodes. They have a porosity in the anode, and then when porosity receive the electron when you charge, it's like an electrostatic to cover on the porosity only, so no chemical reaction. So when this charger more than 100 time, this 100 time, this degradation, but this already okay, this many time than the battery, but now its capacity is very lower than. But in the future, maybe the supercapacitor is the one the energy storage can competition with this one, because this very friendly in the environment, no chemical too much when you compare with the battery. Okay, I think it's have a time. I have some the video for you about the supercapacitor. Take a minute. I change the clip video. Okay, this I am going to research about the supercapacitor, and I have the battery analyzer about the test a charge and discharge. These are battery matrix, and use the software when we change the material for the cathode and anode, and we can test. And we have a software. These are original the equipment from Canada. And then this supercapacitor. If you have a supercapacitor, we can connect to the interface with the computer, and they collect the data, the characteristic or property of the battery, the supercapacitor, and collect the data to charge or discharge the power. This is software you can change many type of the supercapa or battery lithium, battery liquid battery, many things, and then you can collect the data for research. This I prepare for the research in the supercapacitor, and I have a two type. The first type for measure the impedance, the resistance in an AC alternating current. I prepare one centimeter square, and you see they have a positive and negative electrodes, and they have a ratio. This is a ratio about the activated carbon. Think activated carbon. This I use the original from the coconut shell and burn for activated carbon. Activated carbon is very good for conductivity and electrostatics. So and this type is a use of 1 kilogram. If you see in the Racon in the figure, they talk about how much the kilogram can how much to collect the power. So we talk in a kilowatt hour. If supercapa is talk in how much the farad. At the same, because farad in a second, but the kilowatt use it in an hour. So watt per time, almost the same. So this is for the 1 gram. I have a two types. The first one for 1 centimeter square, and this 1 kilogram, and test.
Energy storage.
This is my student to talk about the energy storage, about the how much this can charge and discharge more than 10,000 times, because no chemical reaction inside, only the electrostatic capture and storage inside, and discharge and discharge very fast in a second, and charge discharge but the capacity now is cannot competition with the battery. But in the future, maybe super capacitor or ultra capacitor will be powerful.
100 ถึง 1
You can see in this picture is very fast for charging.
อัดประจุได้เต็มภายในระยะเวลาเพียงระยะสั้น 1-10 วินาทีนะคะ เทียบเท่ากับแบตเตอรี่ลิเธียมไอออนซึ่งใช้ระยะเวลาโดยเฉลี่ย 10-60 นาทีนะคะ และการเช่น activated carbon หรือว่าแกไฟนะคะจะแตกต่างจากแบตเตอรี่ยังไงนะคะ ถึงแม้ว่าการทำงานของแบตเตอรี่กับซูเปอร์คาปาซิเตอร์นะคะจะมีโครงสร้างและองค์ประกอบที่คล้ายๆกันนะคะในส่วนของแบตเตอรี่จะใช้ในการเก็บพลังงานจากการเกิดปฏิกิริยาเคมีระหว่างขั้วไฟฟ้าและสารอิเล็กโทร
From the clip you can see this very fast when charging. You can see it's only the take a time in a second or minute only, and the super capacitor will collect the electron full. So these are easy to make, and also the element electrolytes, anode, cathode electrolytes really simply only 3 layers, no more the element too much, so easy to do. And then after you get the good materials, you can grow like this. These are from the market, and these are my research. So in future maybe we can use a super kappa for the research again. Okay, this is not a polymer ethylene membrane like this one. This is a solid oxide fuel cell. So another type of the fuel cell. Use hydrogen and oxygen too. This no need to heating up, only in the room temperature, and then you can get electricity. But solid oxide fuel cell use the ceramic, and no need to the catalyst. This should be the catalyst like a platinum. But this no need to use, but should be put in the high temperature. And also we can use like methane, only the methane. But this should be use pure hydrogen, like I talked before about the we can get hydrogen and then supply to this get electricity. And then this I design a new one for the solid oxide fuel cell. Like this, it's like a pellet, and have a cathode and anode in the one layer, and I apply to the sensor. In my clip video in today, in maybe the second clip, talk about the hydrocarbon methane. If you remember, methane is connect with the carbon and hydrogen. So if have hydrogen, fuel cell can be detect and generate electricity. So I use this advantage for detect the methane inside. But I use design like this, and then these are electrolytes. Actually, electrolyte in the middle between cathode and anode. But the new design, I use the electrolyte for the substrate and put the anode and cathode on the both of it on the electrolytes, and use the space like this. And also I connect to the tube. This is a ceramic tube. You can put in the furnace in a high temperature, just around 1000 centigrade, and you can apply a gas. You can apply both of hydrogen or methane. Methane is can sucking from the fermentation, like when you have a lot of the food for wet food, throw to the bin or the tanks and cover. Take a time they will generate the gas like a methane gas and apply. So when touched to the my sensor is designed from the fuel cell, they will generate electricity. But I call this one the micro SOFC or micro solid oxide fuel cell. You can see like this. They have these are like a green color because inside the I put top up the material about nickel oxide. Nickel oxide is really bad for the catalyst for cut the hydrocarbon between carbon and hydrogen. When heating up and put to the nickel oxide, will be cut the carbon out, and you can get the hydrogen to generate electricity. And can see the micro picture at the figure. And you can see the layer between the electrolytes and cathode and anodes at the picture. This is the graph for impedance spectrometer. This can talk about the ionics, because between when you are charging your battery or the equipment, both three of the element talk. You ever heard the lithium ion? Ion. Do you know the ion? Ion is like the element is thrown to the electrolytes. So only the impedance spectrometer talk about the ion throw to the electrolytes. So when ion can throw to be between anode and cathode throw to the electrolytes, the circuit is complete. When complete, you can charge and discharge for apply the electricity for your mobile phone or the all electronic energy storage. That is a cross section. And amount of the car resistance, because all the electronics device or the energy storage inside, they have a resistance inside. So the researcher or the factory, they need to reduce the resistance inside, because it's too much. When they generate electricity, it will lost in the device. So the power is not too much to supply to you for your mobile phone, for your my camera. This is the resistance inside. So this one I use biogas. I use the mixed gas and test how we can my sensor detect the methane, how much is it. So this also show that if we hide the methane, my sensor is very good for detection. But when lower the 14%, the detector is an inaccuracy. Yeah, the difference between the mixed gas and the biogas from the factory of Southern Thailand, and test to compare. It generates around 20 voltage millivolts. So we can calculate, we can calibrate this one for the sensor. These are my application about the fuel cell. If you're interested, you can download in the Google. I'm not sure this should be buy or free download. Okay, that's all of my lecture today. So hopefully you can checking about the know-how or knowledge from me about the hydrogen and how to research about the hydrogen power. And I think I have a foresight about the hydrogen, maybe it is good for the environment and energy storage, about the supercapacitor in the future, use the material from activated carbon, and then if become a electronics, this is good for environment too. So any question?
Hello, sir.
Yeah.
I would like to know about the supercapacitor that you were talking about.
Yeah.
Is it in use now commercially? Are industries using it now?
Yeah. Now is in the industry used for the startup the engine, because it's easy to start up, because they take only the short time to charge, and they will use together. The first one is charge this one, and then easy to start up, and another one is a long term, and then can charge. In the industry now is have in the market but not in the main of energy storage. Battery is better, but if I talk about the element inside, this is the organic material, and
Yes.
then if you want to increasing up, now it's nanoparticle. This used from a nano graphite. If you use the activated carbon in the nano, but nano is not easy to do. You use the high technology to do that one. So if maybe if we have a more research, this one maybe can replace the battery in the future and good environment also.
Okay, sir. But is the trend following that supercapacitors will replace batteries in the future?
I think so, because but now in Canada or America, they have developed the supercapacitor, a big the capacity, because the capacity is really low, right? So they need the area for do that one.
Okay,
But the battery now is going smaller but high
smaller.
power, but
Yes,
sometimes
yes.
it's easy to burn. Yeah, that's why everything is trades off. If you got sometimes good, another one is good.
Okay. Thank you, sir, for that answer.
Yeah. Michael, are you there?
I'm right here with you, sir.
Yeah.
I'm right here with you all the time. One of this is not relating to the presentation tonight, but one of the research I saw and it hit me is earlier today I noticed Korean the Koreans were boasting about the creation of the first invisible solar panel, and I remember just bear with me, right? I remember we
Yeah.
had a discussion recently where we looked at solar recycling, where we were talking about the waste from the solar. But they're saying with these new solar panel that was created, it is actually environmentally friendly because it's a combination of titanium dioxide and something else. That's why you get the invisible solar thing past the panel. It's very thin, and we're talking about also in terms of future uses. It's kind of it was fascinating to me, and I said I'm going to talk about it so that I can encourage and my colleagues to go and do the research about it and read up about the invisible solar panel that the Korean has created.
Yeah, yeah. Because of solar, I think the problem in the future, because now it's very installed too much, and they spend around 25 years for guarantee to do. But now they have maybe the 10 years ago now is going to degradation and broken, and then if you throw away in the terrain, they will come to the chemicals contaminate, right? So that your research is good about how we can recycle the solar panels. In a PhD also now is that I have a project about how to recycle, but I ever did that one is not easy because they have a wafer and layer a lot, and then we break this one, and then the silica inside, and also the layer they have a cobalt, titanium, aluminum, and very cadmium. Some if cadmium terabyte very dangerous also. So hopefully you can could recycle and help the earth together.
Okay, sir. It's just a research we're sharing with my colleagues. All right, thanks.
Yeah. Okay. So if no more question, we thank you. Hopefully you take care your health from the attacks of the COVID-19, and hopefully more the injection of the vaccine more. Thank you you watching, and hopefully we can talk each other again. Thank you.
Okay, sir. Thank you very much.
Thank you, sir.
Thank you, sir.